Well, welcome back, everyone, to our synthetic data event. I'm Dr. Viet Nguyen. I am the Chief Standards Implementation Officer here at HL7, and I'm taking the baton from Dan, who helped us to moderate and facilitate this morning session. Hopefully, most of you were able to attend the morning presentations. They were really very informative in terms of the breadth and scope of what's happening with synthetic data. So I would like to introduce you all to Linnell James, who's with the Blue Cross Blue Shield Association, who will be moderating our next session along with our panelists. So Linnell, I'll hand it over to you, and I'll pick it up when you're done with your session.
Thanks, Viet. Appreciate it. Hello, everybody. Linnell James with Blue Cross Blue Shield Association, active with HL7 and working with Viet and Dan as part of activities on the board of HL7. Hopefully, again, many of you saw our three presenters, Jason, Alistair, and Zinal. They're all back with us, and we're going to explore a little bit of the challenges. Let me set up the question with a little background from being involved with the Da Vinci Project, the Gravity Project, and the Fire at Scale Task Force. As a payer, one of the challenges I've seen, and let me preface this by saying, I really wished I'd had time to talk to a couple of my counterparts on the health system side. But from a large payer side, one of the challenges we see is, and I saw it at some of the connectathons, is people would be at the various tables and they would be exchanging hand-built records for testing if we go back several years, and it's gotten better. But I think one of the challenges that payers experience is when we're testing our large systems, for the most part, we're working with our business partners, HIPAA-covered entities, they've signed contracts. So in general, we invite our trading partners in terms of vendor partners as we're building and testing some of the new systems. We bring them into our system and we tokenize our production data. And so we're allowed to easily do scenarios that tie to the real world experiences of payers, whether it's administrative data, prior authorizations, different ages, families, all that stuff's in our live data. And so tokenize, we bring many of our vendor partners into a secure area inside our firewall to do our testing. Well, that's a problem. When we leave our safe firewall, we then don't have the rich data that we have, again, with the multiple different kinds of family situations, different ages, different disease states. So that's one of the challenges that we as payers are looking for, better, robust synthetic data that represents many of the kinds of things we see. So with that as a backdrop of one of the kinds of challenges payers and large entities see when they can test with their secure vendor partners in secure environments, when we're testing at connectathons or doing pilot projects, you're in an environment where testing with your partners with realistic synthetic data is extremely important. So for today, really want to move into a discussion about the title for this, what about the barriers and limitations of the current tools? And I'll give each of the speakers a chance to respond to that general question. Jason, you first.
Sure, thanks, Linnell. I think that I tried to summarize in my talk this morning some of the features that I thought were barriers and limitations. Is the data accessible? Can you modify it? Can you share it without some type of data use agreement? Is it reproducible? Is it explainable? Can you verify or refute the data somehow? What's the statistical accuracy? How heterogeneous is the data? The multiple modalities? Can you use it for health interoperability? Can you use it for deep learning? I think that your use case was about interoperability from a payer perspective, but some of the folks here might have the perspective of education, or they might have the perspective of research. They wanna use it to create a model, And so I think for every synthetic data set, they all have their pros and cons, and I think you need to sort of, there's not one data set out there that solves all problems, I think. And so I think you need to really think about what is your use case and what are you trying to do with the data, and does that data set fulfill those needs or not? And in a lot of cases, I'll just say one last thing, for Cynthia specifically, in the interoperability space, a lot of the questions we got today and a lot of questions we get all the time was, okay, well, you support US Core, but I have this one implementation guide of by the way, like 200. And why don't you support my specific implementation guide in my use case? And the answer is, well, because my team doesn't scale, but it's open source and you do. So you're the best resource to create a model for your use case and to make the post-processing changes required for your IG. So with that, I'll pass the baton on to the next panelist.
Alistair, your perspective on this issue of barriers and limitations for our tooling for test data.
Yeah, I mean, I think one of the things that we struggled with, one is that there's a little bit of a lack of an ecosystem sometimes in Python. I think that's a little bit of an issue for at least me personally. I mean, you dive into all these Java libraries and I'm not very good at Java, and I think that can be quite limiting. And it sort of leads into the second major barrier that at least I see, and it's colored by my perspective as someone who wants to analyze data and use data for sort of either machine learning or treatment is that it's not really obvious what the right way to analyze a whole bunch of FHIR data is really. So through our work, it's very awkward to say validate millions of resources, right? Because nothing is really built to do that, because that's not really how people have used FHIR, and that's fine. But looking forward, at least my perspective is people will start to accumulate these FHIR archives of resources, of data that has been exchanged, and then they'll start to want to do interesting kind of analysis, interesting research, interesting kind of model development using those archives. So the idea of doing analysis using a whole bunch of FHIR resources, there are a few things that exist, but really not that many, and I think it's going to become an increasingly important area in the future. So that's kind of one thing that I'm interested in working on, etc.
Oh, thanks, Alistair. Zinal, your perspective on this challenge of barriers and limitations of our current tools for synthetic and test data.
Thank you, Len. I think this question and the topic itself is highly important, and I agree with the previous, both Jason's and Alistair's assessment. But I think if we take a step back and look from a broader perspective through the life cycle of the database itself, basically the production phase and then the use case, there are challenges and they are different. As Jason mentioned that, well, it depends on the purpose of the data. The database building activity is different, and it involves different challenges. And then once it's built, as Alistair says, well, there are tools and things like that are challenging, or they may readily be there or may not be readily there. So for HRQ's experience and with my own perspective, the way I think for the side of the files that we have built, we have two major challenges. One from the production phase, which is access to the data. It's extremely difficult to get the access to the commercial data where you have sensitive information such as price and things in that nature. So how is it that you can convince them, basically the private vendors, in a way that they can share their data in a way that can be released for the public use? So like preparing a memorandum of agreement and like showcasing that we are going to protect their information with this whole static approach and algorithm, that's in itself a challenge. I think educations of the field, at least some of those large data vendors, about this synthesization term, it will be quite helpful moving forward, not only for ARC, I think for the field itself. So that's being said. The second thing for our purpose is, well, okay, we had BHI be able to convince them to kind of be part of our, along with the CMS and TM, the Medicaid partners. The next thing is we have to build a database that is going to be utilized for actual research. It's not like for testing a computer program or like a clinical profile, which, it has values for sure, But if the file is going to be utilized for actual research to inform the policy, that means the statistical properties of your file has to be on par with the actual files. So that requires a lot of challenging from a weighting or from a sampling perspective. But that's the nature of the work. I think the last thing is, like, as one of the participants asked, like, what information you can synthesize it. That's, again, is highly informed by our data agreements, but it's also informed by the field's needs. So this is the challenges that we have broadly from the phase, the production phase. As Jason said, like, there is no single data source that can answer all the questions. It has to be different. We have to have different files. Going back to the second part, which is mostly around the use case. One of the things that at AHRQ we have, which we have a flagship program called Healthcare Cost and Utilization Project. The reason we call the term project back then is it has the database itself, but has a lot of tools and methods that are developed and can be readily utilized by the researchers in the field. So because this synthetic health data is it's relatively new to the field, I think it also comes with challenges like how is that one can utilize the synthetic files to build the tools for those who understand broadly how to use it, but they may not be fully technically savvy to kind of dig into some of these micro details. So this is something that we are working on it and we are producing, but it's going to take time. But that's another thing I think I sincerely encourage all of those who are involved with the building of the synthetic files to also think equally, like from their end users' perspective. How is it that one can produce the tools in a way that these data files can fit in? So that's like, I don't want to take a lot of time, but those are my, broad takeaways. So
thanks, Zinal. Thanks very much, Zinal. How hard could it be? Hey,
Yeah.
easy peasy. But
if I could jump in just on
yes,
one,
please,
Alistair. I wanted to kind of continue along the lines of the synthesizing the data from a data-driven perspective. And one issue that we ran into when we were working with some researchers who wanted to synthesize data from MIMIC or from some other real-world data set is, at what point do you actually consider the data sufficiently synthetic to publicly release? I think this is actually an unknown sort of research question. If you're doing a rule-based synthesis of data, then it's pretty reasonable to say, hey, this is synthetic and it's not real data. But if you train an extremely high capacity deep learning model on a data set and then generate new data from that model, it's actually not guaranteed to be private from an individual sense. I mean, you could imagine my super fancy deep learning model is actually just reproducing the entire training set, in which case there's no synthetic part about it. It's just outputting the original data again. And so there's clearly a spectrum there between maybe a very sort of high bias, low variance kind of model, which, it's very unlikely to reproduce any training data, to, an extremely high capacity model, which would reproduce the training data. And where you draw the line in terms of, okay, well, you've done some data-driven, you've created a sort of a data-driven synthetic model, and the output of that model is safe for us to publicly release and not release under our data use agreement, is completely unknown. And at least historically, we've taken a very conservative approach and said, sorry, you have to release the synthetic data under the same kind of restrictions as the original data, because we don't have a mechanism of validating or verifying that the synthetic data that you've produced really is synthetic and really isn't sort of reproducing some of the information in the original data set. So I think that's a completely open problem, which is slightly different than the classic membership inference attacks and that kind of differentially private research, but is an area that needs more exploration.
I'm glad you brought it that way, Alistair. I'm actually aware of one of the solutions to the problem you identified just from some work I've been part of, which is under HIPAA, the scientific method. One of the ways you de-identify your data is get rid of all of the things that could be individually identifiable. Well, if you get rid of those things, then you can't use it for the testing. So the other option is a scientific assessment. And I've seen where a consultant was brought in, had access to the original data, access to the raw data, ran some specialized software, and then actually wrote a certification report that identified the percentage chance of re-identification that was to the satisfaction of the lawyers from a health plan. So it is doable. You have to pay for somebody to be that good to, and at least in my understanding, that particular vendor had to get certified and was actually inside the payer's house doing that assessment of the data. But at the end of the day, created a certification letter, an analysis of how he did it. And that was enough to have payer lawyers comfortable releasing that data into the wild because it had been scientifically certified. So that is one of the ways to do it. It's not easy because there's not a bunch of people that do that work, but it is possible. Jason, I see your hand raised. Your turn.
Yeah, that's not foolproof. That, I mean, there's been so much research that to show how you can de-identify data, even if it's been, statistically de-identified according to like expert like testimony. So that may satisfy lawyers, but that I think it's misleading to say that it's proven or scientifically secure, like that. There's just not, I'm unconvinced that that's possible. I mean, there's a whole field of research out there where people make it their academic career to re-identify, de-identify data. And I would, if I had to make a bet, my bet would that they would be able to do it versus that you would be able to safely de-identify the data.
That's possible. I won't deny that. Let's move on. This time, Alistair, you get to start. One of the questions is about use cases. So we've got health equity going on. We've got chronic care, maternal health, behavioral health, quality reporting. There's all these different key use cases that all have dramatic impact, whether it's quality reporting for NCQA or JACO for health systems. There's data that has to be gathered, it has to be used, it has to be reported on. And people need to play with that at Connectathons. They need to try it in production with people with live data. What's your tact on how you, or if and how, Alistair, you can create data unique for some use cases? Are there any that you guys have done? Are there any that are particularly problematic that you've seen? And again, I said health equity, chronic care, maternal health, behavioral health, and quality reporting. Everybody on this call should have at least one of those use cases as one of their challenges for interoperability. Alistair?
Yeah, I mean, I think I can only speak to this a little, but I would say it's sort of the general the general approach of you're not going to be able to sort of cover all these use cases all at once. I think what sort of needs to happen is a framework for actually saying, okay, well, I created some test cases that covered my synthetic test cases that covered my use case, and here they are, and enabling that kind of sharing. And that is, I'm going to very quickly hand off to Jason as honestly as quickly as I can, but I feel like that's kind of what exists, right, in Cynthia in terms of the modeling approach, where, okay, well, we have a whole bunch of use cases that we've worked out with people, but then you're going to have one that's different, obviously. So here's a tool that enables you to sort of create the synthetic data that you can then use for either your more programmatic testing, or maybe something deeper in terms of why you actually want the synthetic data in the first place.
Thanks, Alistair. Jason?
Yeah, I think just to piggyback on what he was saying, I think if you have a data-driven approach, the synthetic data that you can create is limited by what is in your real data. So, if your use case was something that exists today, then you can theoretically create a synthetic data set from data that you have. But if it's something that doesn't exist today, or is a new process or a new disease or new drug, you can't really do it. And I think one of the ideas behind us creating the module builder is we don't know what your use case is, and you should be able to define what it is by creating the module and then run the exporter. And yeah, we don't currently support, all 300, 200 implementation guides out there. But if you have a data analyst who can post-process the data, you can do the edits and the conversions that you need to get it maybe into your implementation guide. Maybe that's translating a terminology or something. So we try to give the tools to people to support use cases that we don't have out of the box.
Thank you. Zinal?
Well, our case is a little bit different, but it's actually highly relevant. So the way AHR, let's take a step back. CIDR is, again, going back to the earlier comments, it is what's the purpose of the data, the use case. It is designed for research, as if you're using the actual database. So the statistical properties of the original files and the static files are like on par with each other. With that, we have a lot of different use cases. Like some of them are like purely done by academic researchers, like they utilize our files and do publications. Like I said, one of them is just published by a cohort of researchers from George Washington at JAMA. But then we have institutions like ISPOR. They would like to use our files to just as one of the recent one that I approved is they would like to use our files for a therapy algorithm for a certain set of cancers for their as part of their teaching materials. And CIDR is a great input for that. So the way we approach it is going back to the earlier question you had, Lionel, is how is it that we can protect the data, right? Because the privacy issues and stuff like that. So in our DUA, we specifically ask them, it is not even okay to attempt to identify an individual. So we kind of specify that because there is no way. There are always actors that are going to be out there kind of try that, no matter what we do, K-anonymity or whatever the other one. So we put those things in place. And the next thing we ask is describe the use case. Once we have these things, we provide the grant and we ask the data custodian and the data owners to have the full responsibility. And every single user is going to be signed into, sign a DOA. So going back to your question of this, the second part is, so for that, our data is utilized for that kind of teaching purpose. But then which we are going to release soon on our website is, it's highly possible to do like a research on maternal health. So I'll give you a unique example. If you're actively currently working on that one, the file that we have developed, we actually follow the individuals on a weekly basis, or like basically on a time horizon for the entire 1 year. If you know the month of the birth, we can have the few months before the birth and few months after the birth from a maternal health case perspective. So we can understand what are the factors that individuals had before during the trimesters of the pregnancy and how that is affecting the delivery or the cost or the complications in that nature. So it can be utilized for those type of questions as well. But like I said, and Jason kind of alluded, it really goes back to the use case. The files that we have developed it can be utilized for a broad range of researchers because we have the commercial Medicare and Medicaid level information in our files. So
thank you, Zinal.
Absolutely.
I'm going to give you somewhat of an easy one that came from the previous session before lunch. Someone was asking about how AHRQ is working with the FDA. And for the audience, let me explain why this is kind of important. One of the top three when we talk about social determinants of health, it's food, housing, and transportation were the first three, the major three, the first press release out of HL7 for the Gravity Project. And the FDA is not only involved with the food and nutrition, but also, I believe, with research. So might you explain how AHRQ works with FDA as part of this test data, if so?
Absolutely. So let me kind of piggyback on the term SDH, as you mentioned. So when we built the SDH file, so I'm going to come back to the side as well. We have reached out to several sister agencies, and FDA one of them, HRSA was another one, CMS was another one. Then we have the Indian Health Services, because Indian Health Services has a unique niche, and they would like to be sure that we are representing their populations in a meaningful way in our SDH files. And we have those which we call it TAP meetings, technical expert panel meetings, and it is usually like a series of meetings. We get their inputs, we incorporate their inputs with the resources that we have available at hand. And at the end, the technical team, the team that's in charge of building the base, come up with the recommendations, and that recommendation goes to our senior leadership. which is also shared at a parallel level with the FDA or others, not necessarily FDA, with other senior leadership, and then come to a compromise. Because if we don't want to come up with a way that we produce a file that is not parallel or like, in different mission that the FDA or other sister agencies have. But that's being said, each agency is different with different mandates, with different tasks and stuff like that. So for CIDR specifically, we have been tasked directly by an executive order from the former administration. Basically, we are tasked to produce a file which has to be nationally representative. It has to include the payment information to support the evidence-based or Price Transparency Act. So with that, we try to reach out to as many agencies as possible. We focus to those agencies where they can support us with the data, such as CMS. The CMS has their research identifiable data, so we need those data to build that kind of files. So throughout the CIDR, we informed FDA, but we did not have a direct relations with them. But it's not that they heard from the news, that they knew that this effort is coming because they were part of this whole executive order. But in general, like there is a link across in all sister agencies. So my supervisor, and I used to work for some time, there is a meeting which called the HHS Data Council. It involves representatives from all agencies, and it's a monthly meeting, and we bring all these challenges, issues, developments, and stuff like that as a panel to discuss, and those representatives brings those issues back to their agencies, kind of to relay what's happening on the other agencies, what are the things that can be done together, what are things that can be done as a complementary. So I hope that answered the question.
Oh, yes, it did. And then for the audience, I've got 2 more good questions, but if some of you have questions, please put them in the chat. You also have a chance to raise your hand and ask the question. Jason, I'm going to start with you. What about the transitions of care? In other words, to mimic the real world from a federally qualified health center, getting transferred to a major health system, then to a specialist. If it's somebody maternal or in the community, there's community health workers and doulas that are involved. That whole sequence probably would be better done with some data. I'm not sure if the data or anything you do helps with the reality of transitions of care that we need to have for real world work streams. Jason?
Yeah, it's a really interesting question. And, I could probably talk about this for an hour on myself, but I think, so there's a couple things here. One, if you used a data-driven approach, you're only going to see what came from the data you have. So let's say you're creating synthetic data from one health system. You're only going to see the person's health record from that one health system. You're not going to see necessarily the data from all the other EHRs where they transferred in. So with Cynthia, it may not be necessarily accurate, but how it works is we have a series of encounters. Someone could have an encounter, say they could go to the emergency room, they could be admitted as an inpatient, they could be discharged, they could have a readmission, they could have a follow-up. That follow-up could be ambulatory, it could be a televisit. The way it works is that in each of these encounters, we have something called provider selection behavior, and you can change these, but the default one, there's a default one, but basically what happens is that the patients will have a number of providers that they'll try to go to, and it could be based on geography, it could be based on all sorts of things. And so they'll go to different systems, they'll go to different providers in the community. At the end, we default output a single longitudinal record that contains all of that. But there is a switch in Cynthia where you could say, no, don't give me that. Split up this record. And so it's a provider-based view. So if there's one patient and they've seen 10 providers, it will split it up into 10 different files where it just shows the view that the provider sees. So if you wanted to do some type of, and those transitions may not be as accurate in the real world, but if you wanted to do something with that kind of data, for what it's worth, we do have those kind of features available.
Great, thank you very much. actually had two questions come in, and they're somewhat similar, which is this: when we talk about this transitions of care, a concern in general that the SME that understands the workflow is probably not the same SME that would be involved in creating this synthetic data. So how do we bridge that gap? And then a related question was, in the continuum of care, there's the technical side of it, but what about the business side of this continuum of care that we need to deal with? How do we bridge this gap between the people that know the workflow but don't understand the related technology versus the technology we use for our testing and pilots? Is that something you've seen? How have you dealt with that? Alistair, I'll start with this easy question for you.
Yeah. It's obviously very challenging. I think this is something that we have been trying to push for sort of a very long time, and it's a non-trivial problem. And I think it's because at least from my perspective, I have to speak from the academic, technical, and sort of clinical sort of research perspective. And when you're trying to basically marry sort of computer science with clinical medicine, you run into a lot of challenges which are fundamentally, cultural, right? In terms of what you value. And in fact, I think we have a paper where, I forget how 6 or 7 years ago, where it's like, hey, we have this gap and we need to somehow address the gap. And it sort of happened in bioinformatics over 10 years of sort of what is a bioinformatician. And if you even think about it, a bioinformatician, it's not like a scientist, it's like a tician, right? It's like a technician. So is this a service role or is this a research role? You start to ask all these questions. At least in my field, computer science, right? Conference publications are very important. In medicine, conference publications are meaningless. And well, not meaningless, but not as highly valued. And so you run into a lot of these sort of cultural sort of barriers in terms of one group sort of incentivized one set of tasks and feels one set of tasks are very important, and the other group feels that another set of tasks are very important. I think the only way to really address this is just to sort of continually have people around each other, aware of each other. I think actually in one of our recent projects with the NIH and Bridge to AI, it's a big experiment on trying to get this to work. And I don't know what the right answer to sort of team science is. Obviously, it's sort of an evolving question, but at least the approach that I've taken is just sort of have people in the room around each other as much as possible. So, for that project, we're sort of, we have these sort of shared group meetings where we have, ethicists, we have clinical staff, we have technical staff, and even within, say, technical staff, right, you have variations of exactly what expertise is there. You have people maybe who know fire very well, you have people who might know cloud, cloud infrastructure very well, and so you just try and get people around each other, get kind of allow for those touch points, and sort of have a sort of shared goal, and try and align those incentives. And that's the closest you can get. And then it just sort of takes time at doing that before you really have everyone working together and humming along. That's the closest I've got to
Well, that's a pretty good answer in terms of the variety of experts you bring to the table. Jason or Zanal, either of you want to add something in?
I think for the products that we develop at HRQ, we have a team with different disciplinary backgrounds. We have MDs on board, we have statisticians on board, economists on board, EPI on board. So anytime we build a database, the database is built by a team, not by an individual. So any kind of research, data elements, anything that's kind of in that nature, the team's input is in it. But beyond that, when we, for the CIDR specifically, we did this with the procurement with NORC and AAR, they also brought like a set of clinicians, or like the one that you mentioned, like a person that's expert in the data privacy, like he used the k-anonymity, which is it's not bad, it's not great, as Jason said, like, some people will get convinced, some not. but they are the ones they know some more than others, and they are the SME. And I think the question itself is a highly relevant one. So anytime a database is built, I think it's going to come down for what purpose is built, what's the intended audience, and what's the use cases. The team should be based on, the SMEs should also kind of be based on that kind of features to kind of before start building the database.
All right.
That's how we do at ARC.
Thank you very much. We've got Russ Leftowich. I see your hand up. If you want to come off mute, you can ask our panel a question. Russ?
Yes, can you hear me?
Yeah, you're coming through loud and clear. Hi, Russ.
So I have not really heard mentioned what for many use cases is the biggest problem with synthetic data. And that is the data that isn't there, that is in real records. And I'm talking about real EHR databases, the record of care for individuals. Things like inactive conditions, a condition that was true at some point in time, but is now known to not be true. It was an encounter diagnosis or a discharge diagnosis, but it was wrong. Laboratory observations that are evidence of a condition that is not in the patient's record. In other words, somebody with laboratory evidence of diabetes doesn't have diabetes on their problem list or anywhere in their record. Local codes for values, a procedure that was requested but never happened, a medication that was prescribed but was never filled, inaccurate data results, observation results. The list is very long. An allergy that somebody was given that medication and nothing happened. Those things are the reality of real records. They're very important to real world data. Linkage between data in an individual record, comorbidities that do not generally exist in any form of synthetic data. And Mimic is great, but it is not a longitudinal record in the sense of an EHR's database. So to me, those are by far the biggest problems for many use cases, like real world data, like cohort recruitment or identification. Those real things in patients' records that are not a clinical guideline-based synthetic data set, because guidelines are guidelines. They're not a script for how people get taken care of. People don't always do what they are advised to do or recommended to do. So those, I think that's what's really in de-identified data. And I'm not discounting the challenges of de-identifying so that it cannot be re-identified, but that is what's missing from trying to use synthetic data for many use cases.
Thank you, Russ. Jason, I'll hit each of you quickly because I think we're going to try to squeeze in one last question before we wrap up. So, Jason?
Yeah, there's a lot in there. So, yes, I think one of the things that very quickly, synthetic data, one of the things we get complaints about is it's not realistic enough, and versus the data is it's too bad and too dirty versus now it's too good and too clean. And it always goes back and forth. We made the decision to make the data on the cleaner edge, and that if you want, you can make the dirty data yourself. There's post-processing algorithms you can do. You can switch a decimal point on an observation value. You can create errors in the different fields. In terms of, we also have things where, for instance, diabetes, people don't like type 2 diabetics don't just instantly become type 2 diabetics. There's a progression. And if you're watching their lab reports, if our system is working correctly, you should see their certain lab reports inch up until they get diagnosed. And so we try to do these things, but it all comes down to the accuracy of the model. We are not using real data so that you can use our data. We've heard today about how some of these, you have to have a data use agreement to even touch it. Well, we offer a solution where you don't need that. But yes, that means that there are weaknesses with it, but we also try to provide the tools where we can address some of those gaps that Russ mentioned. I'll just leave it at that.
Thanks, Alistair. Anything you want to add before I give a new question to Zinal?
Yeah,
Alistair?
I mean, it's a great point. I think this is one of the real key challenges in synthetic data, in just covering all these edge cases and thinking through all the different ways that you could have inconsistent information, and that happens a ton in Mimic, obviously in the inpatient context, but it still happens. So I think the tension here really is, which problem do you think is easier to solve? And what I mean by that is, do you think the synthetic data problem is easier to solve? That is, technically covering these edge cases, figuring it out, and coming up with algorithms which reasonably reproduce this kind of phenomenon in the data, and then you can use that for all your sort of useful use cases. Do you think that technical problem is easy or hard to solve? I mean, it's obviously a hard problem, but the question is that easier than the people problem of de-identifying a data set and sharing that broadly? And as much as I'm a huge proponent of de-identification, Mimic has been out for at least 10 years. It's at least 60,000 patients, and it's at least 30,000 researchers who use it. So if you multiply all those numbers together and estimate a risk of sort of re-identification or a risk of harm to patients, it's very, very low, right? That doesn't mean that it's easy to convince people to share de-identified data. So it's sort of, which problem do you think is harder? And I honestly could not say which problem I think is harder right now. So there's probably room for both approaches, is, I guess, a very balanced and fair answer.
All right, we got 2 minutes, so we're going to do a 30-second drill here. So the question is, and Zinal, you get to start, 30 seconds. Where does AI fit in this synthetic data, if at all?
Oh, it does fit in many components of the files that we have built. I'll just give you one example. Like our files are based on actual files, like real information from the field. And there are, for many cases, we have missing information. How is it that we can utilize some of these AI algorithms to kind of fill in those missings in the information, like deep learning algorithms, like random, like I said, any of these like machine learning approaches that has been there for decades can be utilized for information that's highly helpful for the field. So I see like a lot of use cases for that kind of activities.
Cool.
Along with,
An opportunity to have the
cases.
AI fill in the missing data. Jason?
Yes.
Alistair?
It wouldn't be a panel if we didn't talk about ChatGPT somewhere, right?
Right.
No, I mean, I think structuring data with large language models is a very interesting area that I think there are some working groups starting with, and so I think that's sort of an interesting angle. Obviously, our models are getting better at modeling real world distributions and then replicating data which match those real world distributions, and that's very useful from a synthetic kind of data point of view. But there are, like I sort of mentioned earlier, still real questions as to whether the output of these models can truly be considered as safe, as private. And of course, there are mechanisms to do that through differential privacy, but they are still areas of research. So I think still a ways to go there, but for sure you can imagine data-driven models for generating synthetic data are going to, I think, increase in sort of their frequency and their use.
Great. This panel, Alistair, Jason, Zinal, fantastic. We didn't get to international perspective and challenges, but we got some really good stuff covered. Thank you for the time and attention. And I believe we're a wrap. And Viet, we turn it back over to you.
Thank you for having us.
All right. Well, thank you so much. That was a great discussion. And hopefully the participants are gaining a lot of information out of this. We really appreciate all the engagement in the chat and the questions. It really helps us to kind of understand where you all are and where the opportunities are. And one question we want to get your perspective as a community is, as you listen to these presentations and to the extent you know about HL7 and some of the activities we do, think about what's next. What would you like to see next in terms of advancing this type of work and these presentations, so that we can start to continue to advance the efforts around synthetic data and support your testing. So I will be moderating our next panel, which is a really great group of presenters around the use of synthetic data for testing. And so what I'll do is I'll present each presenter as they come up. And we'll be starting with Rob Scanlon, who is the principal software engineer at MITRE, where he develops open source software for the health IT domain. He currently leads the development of Inferno, and we'll learn a lot about Inferno through this presentation, which is a fire conformance testing tool sponsored by the Office of the National Coordinator for Health IT. And he previously served as the principal investigator for MITRE's Crucible fire testing project. So I will hand off to Rob, and then I'll come back when you're all done. Please put your questions in the chat, and we'll try to address them either during the presentation or in the panel discussion that we'll have when the presenters complete the presentation. So thank you. Go ahead, Rob.
Thanks. Quick mic check. Can you hear me? My screen.
Yes, we can hear you.
Okay, great. Thanks, everyone. I'm Rob Scanlon. I really appreciate being able to talk to this group. This is this has been really interesting for me, and I've enjoyed all the conversations that it spurred. This is something that data in general is a big part of testing, and on the Inferno team, we do testing. So I only have about 10 minutes to go through a whole bunch of content here. So I won't. I'll kind of skip over about me, but just as a quick overview, what I want to cover is I'm going to provide a brief overview of Inferno and conformance testing and Inferno's methodology for conformance testing, and then I'll talk about data. We're here to talk about the data aspects of this. So how you use data, or how we use data in Inferno testing. I'm going to provide one example of how we used and created a test data set for our US core tests, and then just provide a couple of observations at the end. So very briefly, Inferno, if you're not familiar with it or if you haven't heard of it, it's a fire conformance testing tool. It was originally built to support ONC's certification program and their G10 certification criteria, which has to do with providing patient data records over a common interface. However, it is very much designed to be extended to other use cases beyond certification. A core aspect of Inferno is extensibility, and sort of broadly, you can think of Inferno as Ruby's a programming language, a Ruby application framework for developing really realistic tests and that run test agents. It's designed to be portable, so you can run it locally, download the tests, so you can run it on your local machine or behind a firewall, or in a shared service for sort of ease of use. And we're really dedicated to transparency. So this is all open source, Apache 2 license, because we think transparency when it comes to test systems is really important. A couple of online resources. If you went to inferno.healthit.gov, that's ONC's hosted instance of Inferno, and it hosts the tests that are relevant to their certification program, as well as several other tests that are outside of their certification program, but also relevant to the types of things that they're interested in. Or you can go to inferno-framework.github.io, which is the documentation site. So that's where you can learn how to author your own tests, or run a copy of tests that were developed locally on your own machine or inside your firewall. I'm not going to spend a lot of time on sort of describing why conformance testing is important, but I just want to mention that there's a whole bunch of different types of testing that you might want to do, but Inferno focuses on standards conformance. The tests that are in Inferno aren't going to find every problem with every implementation out there. It's just not practical, and it's not within the scope of what we're trying to do. But we are trying to find interoperability issues earlier in the development lifecycle, just to make it cheaper for implementers to sort of fix these problems, as soon as they can find them. But there are all these secondary benefits of having tests that focus on the standards, such as providing an unambiguous representation of the requirements. It's kind of hard to fake tests because they have to be very specific by their nature. And it's also nice to have sort of an independent mediator if there are multiple implementers out there that disagree on some details in a standard. It's nice to have sort of a set of tests that people can look at and say, oh, okay, the tests say this or that, right? So a lot of times it's a good way to sort of resolve issues. Now, Inferno, there's a lot of different kinds of ways that you can make a conformance testing system, and there are other, Inferno is just one FHIR test tool that is out there. There are several others, but the way Inferno works is tests are written in Ruby, which is a full-featured programming language, and they're targeted very specifically at FHIR implementation guides. So you're not trying to test the whole FHIR spec, but rather write realistic tests write good tests that target implementation guides. So very focused. You take those tests and you package them into test applications that we call test kits. So you can do that very easily. It makes it so anybody can download and run just those tests wherever they might want to. And test authors have just a lot of flexibility in how to best test systems. We do provide some helper tools to make it easy to test in certain ways, but we try not to impose too many requirements on how an implementation guide and actors within that are tested. Another just important aspect that we try to keep in mind is to avoid imposing artificial requirements on systems under test. So we try to stick to the standards and not say, hey, you have to also support this other thing in order to make the tests work. So that's just sort of an important aspect of how we write tests. So I said, so Inferno is a framework, and you use it to build these test applications that we call test kits. Here's a list of test kits that our team has written. So obviously we have the G10, that's the ONC Standardized API Test Kit. That's very specific to the ONC certification. But we've written several other test kits that target different implementation guides and therefore different use cases. And if you want to see other test kits that my team has written, you can go to the Inferno Framework organization and just search for test kit. Now, we do encourage other people to write their own test kits, and so we don't have a lot of visibility into necessarily every test kit that's been written using Inferno. So just sort of keep that in mind. This isn't sort of the universe of everything that can be written with Inferno. So now kind of switching over to to talk a little bit about how we use data inside of Inferno tests. Something that we've found is that the test data is really highly dependent on the implementation guide or use case and the test approach that the test authors essentially want to do. So it's hard to have a sort of single universal set of test data or an approach to creating test data, because it really depends on what the focus of the standards are and sort of the values of the tester and the test goals essentially. Something that might be a little surprising, I think, for people when they start using some of the Inferno tests is that tests may or may not require specific test data to be preloaded by the system under test. So I think a lot of test systems out there say first load this data and then we'll check to see if you can send it. We found that it's helpful to write tests such that implementers can provide their own test data, and then we provide criteria about that test data to basically say this is the kind of test data that we would these are all the things you have to show us broadly and send us the data, and we'll take a look and then let you know if it is conformant or not. Importantly, the tests that we write are open, and so the test data included in tests also have to be open. So that sort of, I think, limits the kind of tests that you might want to include or data that you might want to include in tests. And also that tests really need to be, even if you're not providing data that has to be preloaded, it's really helpful to provide reference implementations that the tests can run against that have data, so you can see the test running. It's sort of an ease of use thing for anyone trying to execute the tests. I think importantly, it's something that we spend a decent amount of time thinking about is what makes a good conformance test data set. And this might be different for different use cases from a conformance perspective. Obviously, we want it to be correct. That's really important. But we want it to be complete also. So it sort of demonstrates all the different kinds of things that are required by the standard. And a lot of times in FHIR, those fields that are that have to be supported are tagged with something called the must support flag, essentially. And so it's not just enough to have valid resources, but also you have to have a good range of resources so that you can be confident that a system can actually support everything that has to be supported. Realistic is nice, but it's not, they don't have to be 100% realistic. It's, from our perspective, it's really about making it so that you, realistic enough so that there aren't other sort of real world requirements that real systems would have that would prevent them from loading unrealistic data. Concise is really helpful too from a conformance testing perspective. Really want to avoid redundancy in the data to aid in the portability. We find that from a, we try to make tests as easy to use as possible. And if there's a lot of data and it takes a long time to test, people will test less often. And then also open, obviously, sort of is helpful too. But I just will say that these aren't hard and fast rules. There isn't any universal sort of best data set. Trade-offs are necessary. So you just sort of have to keep that in mind. I want to very briefly talk about one example of how we use test data in one of our test kits. So we have a test kit specifically for US core, which is actually reused in the G10 certification test kit. But those tests do not require systems to load specific data. And in part because there is no write requirement. So we can, as a first step, write data to a system under test. And then also there's just a lot of variability that's acceptable in US core for systems to actually support. So saying you have to support these specific codes and whatnot might not be realistic. But we still wanted to provide a test data set to demonstrate the Inferno tests so you can see the tests running. And also for systems that that want to, they can load the data, our data up and sort of demonstrate that if they're able to use our test data. And so what we ended up doing in this case is, so we looked around for tools that that do a good job creating US core data. And so Cynthia, which we've been talking about quite a bit today, is really particularly good about that. And so we took Cynthia, generated a large set of data and then post-processed it. And so Cynthia checks off a whole bunch of things that are important to us, like it's correct, realistic, and open. The sort of downside for our perspective, it's not that concise. There's a lot of sort of redundancy if you really look at it from a conformance perspective. And there are a handful of gaps. And so, so our approach was to take Cynthia, run it, post-process it, and try to trim down the amount of data that comes out of the cohort. So basically identify good patients within those that were generated that sort of match as many of the requirements as possible. And sort of as a last step, we can actually go and combine the patient records into a sort of a now unrealistic single patient record that has sort of like, that's a combination of a whole bunch of different patients. But the upside is that you have a single patient with sort of that represents everything that might happen to a patient. And then any of the remaining gaps we filled with CAN data. And so this is all open source. If you went to our Inferno framework GitHub org, you can sort of find it by poking around there. Or you can hop on the reference server that we have on inferno.healthit.gov, and that data is loaded up there. Now, this was done a couple of years ago, and I know Cynthia has recently done some work to have this be more part of their Cynthia itself, but it's sort of the same sort of concept. And now, quickly to wrap up, I'm sure I'm over time. Just a couple of observations. The variability in requirements across FHIR implementation guides just makes it really hard for have a single universal solution. I just want to point out the realistic test data is desired, but it's absolutely not the only characteristic that's important from a conformance perspective. And we found hand-authored or synthetic data is usually like pretty good, but there isn't a ton of tooling for a diverse set of use cases. And with that, I think I'll sort of wrap up. Thank you. I think you might be muted yet.
Yeah, Viet, you're muted.
I'm sorry, double muted. Thank you so much, Rob. If you'd like to go ahead and relinquish the share, and I'll go ahead and introduce our next presenter, Joey Legrand, who's a pharmacist with advanced training in health informatics and technical competency in a number of programming language, SQL, and other data engineering tools. He's the founder of the Code RX organization for pharmacists and other healthcare professionals who look to develop their skill sets and technology and apply it towards building tools that are useful. He's the lead application analyst at Vanderbilt University Medical Center with a focus on acute clinical workflows, clinical decision support, and reporting. He's here because he has a strong interest in synthetic health data as part of the Synthetic Health Data Challenge, sponsored by the Health and Human Services and the Office of the National Coordinator back in 2021. He led a team of 6 pharmacists from CodeRx to win the competition with an open source solution that increased the realism and diversity of medications prescribed using synthetic patients in Cynthia. So he continues to work with the CodeRx project and continuing to develop open source data. So we look forward to hearing about how they've applied their subject matter expertise around pharmacy into the leveraging the synthetic and Cynthia data tools. Handing it off to you, Joey.
Thanks, Viet. Thanks for the intro, and I'm very happy to be here. I have less synthetic data and FHIR experience than most of the other people on this panel, but I will share with you what I can. So as Viet said, my name is Joey Legrand. I'm a pharmacist. I've got a master's in health informatics. Been at Vanderbilt for about close to a decade, working in the EHR with health IT. And in my spare time, founded this organization called CodeRx, and this was my introduction to synthetic data. Because we started looking at Cynthia as a source of basically just CSV files, not even FHIR data, that was kind of representative of healthcare data that we could potentially upload to a database and educate people on SQL against kind of like what they might see in a healthcare system. And starting to look at the data, we found that it was kind of missing some realism in the medication space, which is what we were primarily focused on. So this is what we focused on fixing with this challenge, the Synthetic Health Data Challenge that we competed in 2021. If you're interested in CodeRx at all, our website's coderx.io. It's right there. But what we looked at asthma for the challenge. And so when we originally looked at Cynthia, this is kind of like what we saw for pediatric asthma patients and any asthma patient really, regardless of age. So 100% of the population was getting a single product and a single strength of that product. And it's not just asthma, there's other modules that are kind of like this where, you know, as a pharmacist that I've worked in retail pharmacy for 5 years, we dispense all this stuff for tons of people. And, you know, why is that a problem? It's because within most disease states, people are taking a variety of medication products and strengths. There's not typically a one size fits all treatment for most things. If it were, it would look kind of like this. This is a book from Mr. Pine's Purple House, which I just read to my daughter yesterday. So I thought I'd throw this in here. Everybody in the same house, same White House, in the same street, same medications, just not realistic. And so part of the challenge was having to use open data sources to solve a problem that we wanted to tackle. So we looked at AHRQ MAPS, which was mentioned previously in this conference. One of the things that MAPS is a nationwide survey. One of the things that patients report on is what medications they're taking. And so MAPS provides NDC level information, National Drug Code level information on prescriptions that patients have, and it also has demographic information. So we're able to kind of compare a population in Cynthia with a population in MAPS for the same age range and the same medications. And this is what we saw where, you know, Flovent 44 microgram is the most common one in MAPS, but there's a variety of other medications and different kind of distributions in this population. And so there you can see Cynthia is not representative of a US population. Why is it hard? In Cynthia, as Jason talked about the module builder before, people can add steps to these modules, but typically the medication order part of the FHIR medication order step is hard-coded with an RX norm, RX QE of usually like one product, or maybe there's a few products in a given module. Any sort of distribution about like what percent of patients get this versus this have to be manually maintained and kind of manually entered into these modules. So this is why everybody was getting this product, because that step in this module was that specific RX QE for the specific product. So what we did was we built a Python module which exists outside of Cynthia called MDT, or Medication Diversification Tool. This is also open source. It's Apache 2.0 license. And what it does is instead of calling that specific Rx GUI, it calls a submodule that gets generated by MDT. The submodule is JSON, and it calls out to CSV files that have those distributions broken down in a two-step approach. The first step is how likely is this patient to get an ingredient? So in this case, fluticasone, budesonide, beclomethasone. And if they're prescribed fluticasone, for instance, what's the likelihood they're going to get the 44 microgram product versus the 110 microgram product? So that's the two-step approach that the submodule takes. It allows the user to input medication settings for Rx class IDs to include or exclude Rx norm, Rx GUIs, and at the ingredient level to include or exclude and other Rx norm settings, like whether you want only single ingredient products, only multiple ingredient products, and what dose forms you want to include. And optionally, you can chop up the distributions by age ranges, like pediatric versus adult, gender, or state of residence that is captured in MEPS. And it outputs the Synthia submodule JSON file and a CSV file that you can integrate back into Synthia to replace your medication block with a call submodule block. This is the link to our GitHub repo for medication diversification. Again, open source, you can download it and run it yourself. Other thing to note is we not only ran this locally, but we've also done 2 pull requests back to Synthia to integrate medications for the asthma submodule or the asthma module for maintenance inhaler and rescue inhaler. So you can do this locally, but you can also contribute back to the Synthia project by contributing the submodules that get generated out of this. So this is, again, what the normal view looks like, kind of a step. This, you can't even really see it here, but this up here is what the submodule that gets spit out of MDT looks like. So it goes super wide because there's so many different medication products just for asthma. And so that's just kind of, it would be very tedious and error prone to build and maintain manually, but we generate it programmatically with these JSON files. So zooming into just the beginning of that, you can see it starts here and you go to the ingredient distribution step where you go 1, 2, or 3 different ingredients for this asthma, and then the product distribution step where it determines what product you get, which is why it's so wide because there's lots of products. After you integrate it back into Synthia, this is what it looks like. So top is Synthia by itself, next is MEPS, and the third one is Synthia plus MDT, which looks very much like MEPS. There's a little bit of differentiation due to the randomness that Synthia generates. This is the framework. We combine Rx class, Rx norm, which is visualized via Rx nav, and then MEPS to output the JSON and CSV. The other thing I want to mention right here is that because Rx class and Rx nav are supported by NLM and have an online GUI, like graphical user interface, it makes it really easy for a clinical person to work with a developer to kind of browse the classes and ingredients in these user interfaces and say, oh, I would like to kind of define my medications as this Rx class ID combined with this Rx norm ID. And they can go through iterations pretty quickly just by inputting those settings into the tool. This is what the JSON file looks like. As part of it looks like on the left, and the right is the CSV file that gets output. The other thing we do is we make it easy to see kind of the population level distributions without having to dig into the CSV file. So you can kind of get a gut check of like, yeah, that looks about right. That doesn't look right to me. And you know, a developer could run this and give this file back to a clinical person and say, does this look right? Do more people get fluticasone than beclomethasone? What does that look like to you? And kind of work back and forth until you get something that looks realistic. This is the product level distribution, same thing, but instead of ingredients, you get like a specific strength of a specific product. We just published this as well in Jamia Open. So this is coming out in October. If you wanted to read it today, it's out there. There's a QR code that links you right to it. It's called Novel Method to Create Realistic Synthetic Medication Data. I think I'm running out of time, so I'm gonna skip ahead. You kind of know, most of this is just benefits of synthetic data. Limitations here is that we are defining medications at the medication level, not at the disease state level for those inputs. So there's a chance that a medication is used to treat 2 different things. If you're using it in just one module, it could be misrepresented as, you know, because it might be used to treat something else. That might be why the patient was prescribed in MEPS data. There's lots of additional features we'd love to add to MDT. I'll call some big ones. One is like dose increases over time or dose changes over time. Even though the meds are more diverse, they're kind of their patients on that for the rest of their life in Synthia. The other thing would be to model drug adherence. I think every patient in Cynthia is super adherent. They fill their medication on time, 100% on time, and never miss a fill, which we know is not realistic. And there's other enhancements we'd love to make, but I'm happy to talk to you about those during the Q&A, or if you want to jump over to coderex.io, join our Slack, we can chat about it there. Also, there's links to the open source repo and a tip sheet for how to use it if you want to review that at some point as well. So thank you very much.
Great. Thank you so much, Joey. Again, if you have questions, please put them in the chat or the Q&A. We'll try to address them during the panel discussion. Next up, we have Bryn Rhodes, who is the Director of Standards Strategy at Smile Digital Health. He's also a co-chair of the HL7 Clinical Decision Work Group and editor of the HL7 Clinical Quality Language, or CQL, as well as the FHIR Clinical Reasoning module. He has over 20 years of experience in development and architecture for information systems, and he has a number of initiatives around working in interoperability and computable clinical knowledge. And on a personal note, he's also one of my call first if you have a question that around clinical reasoning and how to use it. So I personally have learned a lot from him and appreciate him being here. So I'll hand it over to you, Bryn.
Thank you, Viet. Can you hear me all right?
Yes, we can hear you.
All right. So today, I just wanted to talk about some of the things that we've done, some of the approaches we've taken for testing and the use of synthetic data in testing quality improvement artifacts for the various projects that we've used them in. This is a slide that I start with quite a bit. It depicts kind of all the stakeholders involved in a quality improvement ecosystem. So starting with research, synthesizing that research into best practices, distributing those best practices through clinical decision support, having those impact patient care, and then measurement and analytics to try to understand how that impact took place, what the outcome of those were, and ultimately reporting those and effectively back to research, completing that cycle, ideally. So where we've done a lot of testing of the content that we've built is in the recommendation space. So in translating a best practice from a narrative to a computable representation that can be executed as a decision support service. And through the specification of quality measures to test outcomes, determine adherence to a process, those types of measures. So the test data strategies that we've used vary widely, depending on what the content is, how much capacity you have, what kind of skills you have on the team that's building. And they start, they go from very manual creation by hand, or go through each of those, up through generated approaches, including Cynthia and other tooling approaches. Depending on who you have on the team, you take different approaches and how much time you have to do it. So first is just manual test data creation. So using something as simple as Notepad, there's VS Code. You can use, there are several plugins to VS Code that facilitate manual creation, make that a little better. Notepad++ is another environment that has a lot of useful extensions that facilitate creating this kind of data by hand. And then just copy and paste from GitHub. There are lots of data sets available at this point that you can draw from. But in the very lowest level, most basic case, we typically create tests by hand, and it's tedious and requires a lot of specific technical expertise to use and do. So the kind of next step there is manual test for data creation. So form assisted. There's MADI tool, the Measure Authoring Development Integrated Environment, that is being developed. It's a replacement for the current Measure Authoring tool. Both those support creation of data by example, so by form. You can build your FHIR resources by filling out values in a particular form. It's very precise. but it's also a very manual process. You have to go through a lot of steps. ClinFire is another similar tool. It's a great tool for doing this kind of thing, but it's a very manual process, and you have to build the data up piece by piece. And that works for building specific test cases, but it's also a very effort-intensive process. So another piece that we've looked at is the use of Cynthia, and the Cynthia team has provided several demonstrations over the years on using Cynthia. They've even put together slides and a particular, and there's a recording there. I've got links there. They walk through building a Cynthia module specifically for, and I think it's a colorectal cancer screening measure, and building up a measure. And that's a very useful tool, especially if you need to build large sets of data, if you're trying to actually simulate population. If you're going for unit testing, the amount of effort involved to build and maintain the Cynthia module versus just maintaining the resources themselves in unit test, there's a point of balance there. So there's trade-offs depending on how much data you want to build. There's a cutoff point. So there's also some other tools that we've built up over the years for doing this sort of thing. This one takes fire profile definitions as input, similar to what some of the other tools will do. It just looks at all of the element definitions in your profile, and then spits out a resource that complies with that profile by choosing random values for elements that are required, and those values then are constrained by the invariant definitions in the profile. So what you get out of this is it's a great tool for generating example data, especially as part of an implementation guide, but it's just pure random data that comes out. So it's a very simple thing. You can just point it at a set of structure definitions and get out a set of resources. But it's often just completely random data. So there's another set of tooling on top of that you can provide a spreadsheet that ideally the clinical informaticist or even the clinical subject matter expert can use to create created test cases. Each line test case or in this spreadsheet is a test case. Each column is the value of a data element supported by a profile. And so instead of generating a completely random value, it generates a resource with value from this spreadsheet. So this gives us a way then to have a clinical SME give us test cases that are curated and validated from a clinical perspective in a format that they're used to using, but then still use tooling that is informed by the profiles to generate conformant resources for each of these test cases. Each line generates 70 or 80 resources depending on how many columns are in there. So you get a pretty exhaustive set of test cases, and they're clinically validated and maintained in a way that clinical SMEs can communicate and give that information. So that's been a really useful tool for testing as well. And finally, we've actually spent some time building just random test case generation using CQL itself. So we built this is an example random test case. You give it a patient reference, a couple variables to this function, and it will actually go out and based on the value sets, it will pick a random code from the value set. It will pick a random code for the procedures or the encounters. It will pick random values. It's the same kind of thing, but maintained. And if you have an author that's used to building up CQL, this is a very straightforward approach to building that kind of random data. And again, it conforms to the quality measure because it's built by picking random values from value sets used within the quality measure or decision support rule. And finally, there are cases where we can actually derive synthetic data from real world data. We'll be looking at one of these examples in the upcoming Connectathon at the clinical reasoning track. There's a claims data scenario. Got the link there. It is a certified HIPAA compliant anonymized data set from a national payer. It's conforming to Karen Blue Button. And the scenario is just, can we take this data that's representative of administrative content and use it to derive synthetic data based on the claims? For example, if the claim indicates a procedure occurred, produce a procedure resource to represent that actual event. We can also look at, can we actually modify the measure specification to make use of the administrative data? Or can we pull data from the administrative data by inferring clinical data from? So both of those approaches are things we'll be looking at in the upcoming Connectathon. And then I just wanted to highlight a couple of the test data challenges that we have in this space. So creation and maintenance really need clinical and terminological input to get good test cases. There's really just not any substitute there. And it's also date sensitive, right? It always needs to be refreshed or parameterized. So we have some tooling around just once you get a good data set, how do you keep that fresh so that you can make it part of a continuous integration build and it doesn't go stale. And then just some usability challenges. For Fire IGs, we build Fire test cases. But often we found that when we go to try to test this content at an institution, they don't have a way to actually consume that Fire data. They can't pull it in. There's no write interface on their Fire API. And so they actually have to manually enter the data, even though we've provided, an interoperable data set for testing. So that's been a big challenge that we've faced as well. So that is it.
Thanks, Bryn. Oh, your screen is blank. Oh, great. Thanks so much, Bryn. I think we'll have more discussion around the work you're doing when we go have the panel discussion. But next up, I'd like to introduce Adam Wilcox. Excuse me. Adam is a professor of medicine and director of the Center for Applied Clinical Informatics, the Institute of Informatics at the Washington University in St. Louis, the School of Medicine. He's had broad experience, both applied in research informatics in academia and healthcare delivery organizations, and he leads strategy activities related to application of informatics tools and methods to improve clinical care and research. He's led data and analytics strategy development to improve care delivery and transformation, along with clinical decision support implementations and development of primary care and care management health record systems. He's also involved in population health research and is a fellow of the American College of Medical Informatics. He's authored over 100 book chapters, peer-reviewed articles, and is a member of the PCORI methodology committee, where he's focused on informatics and investigating issues. And just another example of how relatively small our informatics community is, at least it was 20 years ago when I started. My first class at the University of Utah's Biomedical Informatics fellowship program was with Adam and learning how to write code in Java. So he gets credit for me to understand at least how to read and write some simple code in Java. So thanks, Adam. You're up.
Thanks. Just checking if you can hear me.
Yes, we can hear you. Thank you.
Okay, I'm not able to start the video, but so this is a little shift in directions. Instead of talking about synthetic data for testing, I'm actually going to talk a little bit more about testing synthetic data and the evaluating of it. So the way I'd summarize this is that, we often get, as we've been working with synthetic data at Washington University, primarily MD clone, we get questions about in the following. Does it work? Like, does it work for analysis? Does it work? Does it actually preserve privacy? How does it work and how do we use it? And I want to talk about the ones in bold here, specifically the does it work, that we've done 6 functional validations that I'm going to go through and 5 privacy validations. that'll kind of answer all of these questions that we've been trying to look at regarding that. And then I want to talk a little bit about, so what does that mean and how do we use synthetic data? Because of this, I'm going to actually be going really quickly through a lot of these slides in terms of the demonstrations, but hopefully you'll get the gist. The most important numbers here are not what we're going to show here, but the 11 studies that we've done. So first study was done by Dr. Randy Foraker, and a lot of this is based on the National COVID Cohort Collaborative, or N3C, where we were participating. And she did an analysis of looking at the distributions of key features for a COVID positive cohort of the MD clone synthetic data derivative and the original data that we had, answering the question, does it look the same? Which I'm not going to go through each of these numbers, but basically it does. And then the second use case tried to then test predictive models for assessing the risk of admission among COVID patients, and basically answering, does it work the same? In that case, yes, it did. So we were able to get the same analytic results for predictive models as we were with synthetic data as real data. And then next, does it work better than other approaches? This is the first of the second, where we're comparing it actually to what you could do with HIPAA de-identified data. So this was, and we're all kind of familiar with these epidemiologic curves during the pandemic that we were looking at. And so we tracked whether the epidemiologic curves for a population would look similar with synthetic data versus real data. And you can see the red being synthetic data, blue being original. Those are pretty tight lines in terms of meaning for that. And this is important because it shows it is better than HIPAA de-identified data, because for a population, you couldn't have the dates, the resolution of dates at this level. And then later we did another test, which is also using these the epidemiologic curves, but we did it narrowed down to individual zip codes. And while we did find it didn't work when we got down to zip codes where there wasn't a lot of data, especially rural areas where the populations were low, for most of the cases, it worked just as well. And so for tests, admissions, cases, and then deaths, you can see the blue versus the red in terms of that mapping for these different curves, and it worked just as well. And so this is, we've showed it, we can do it temporally better than HIPAA de-identified data, and to the zip code level, which HIPAA de-identified data cannot as well. And then finally, looking at what can we do differently with this? And so we tried to take the data, because we remember during COVID, there was a lot of the waves the waves of infection moved regionally. So what would we want to learn from other people who have faced this? Can we predict our peak based on someone else's peak? And so we took data from different states, Massachusetts and North Carolina, which were pretty well represented. And we took the data leading up to the peak and tried to actually determine if we could determine the peak from there. So, and we showed that, yes, we could time the inflection point, and if there wasn't an inflection point, we didn't see one as well. So trying to make this prediction from shared data, and this is important with synthetic data, because this is like we weren't sharing data very much during the pandemic. N3C was an interesting example of that, but wide sharing of data, we consider that synthetic data is potentially a good possibility for doing that. And then finally, the final test of function was also testing, does it work the same, was just a reproduction of another study that was predicting case severity for hospitalized patients. No surprise, we got the same result as the published paper. So now we've done these tests of functionality. Does it work for analysis? Now, does it work for privacy preserving? And so the first test we did was we tried to see, does anyone look the same? So we did a test of uniqueness of synthetic data, and Noah Zamstein, who's with MD Clone, is on this call, and she did the work for this, so I want to recognize her there. But she looked at, do any of the rows in the synthetic data match the original data? And basically we found that, for a very small number, yes, they were exact matches, but most of those times it was because there was very little data. So yes, it preserves privacy in the sense that people don't look the same between synthetic data and real data. And then we tried to do it in a kind of more advanced. And so I'm using this image from Mission Impossible, because we used an adversarial approach where we had someone actually try to attack the system using available information such as voter records and public information to see if that person was in the population from which the data was created. So trying to answer, can you identify people, and can you identify people uniquely in that? And this is an analysis done here at Washington University with that. And this kind of summarized what we did. And basically, this shows that when we were looking at real data versus synthetic data, first of all, with real data, they could sometimes say, oh yes, I think this person's in this population, and they could be more confident about it, and when they were confident about it, they were more likely to be right. Whereas with synthetic data, they were less likely to be confident, and when they were confident about it, they were more likely to be wrong. And so it does protect people in terms of an adversarial attack, and we also automated that adversarial attack in the same way and demonstrated that it couldn't find the individuals in some ways. I'm not going to go through the details of these exact ones. This is just throwing a lot of data at you so you can kind of understand the levels of analysis that we've done. And then finally, we wanted to look at information gain, and this was based on a project we were doing where we're linking data sets together. And when you link data sets, if I have the data initially and you've got the data from another source, the challenge is that there's fingerprints of data, and if we just link them together, even if they're both HIPAA de-identified, or if we link them and then HIPAA de-identify them, I can tell by the fingerprint who is whom, and I may be able to draw information about an individual that I didn't have originally on that. And so we tried to test, first of all, whether those fingerprints were maintained in synthetic data, and we found out no, they're not. But even when they were identified, we looked at information gain and found that we actually couldn't gain information about them, except in some rare cases that could be solved by some basic censoring. So I've tried to kind of provide here a really fast review of the studies that we've done on synthetic data, answering those questions in those 11 different studies. We were trying to figure out if it really worked, and honestly, we were surprised that it did as well as it did. Myself, I was especially surprised with the information gain. I didn't think it would perform as well there, but we were pretty pleased with the results. But then the question comes up, okay, so it works. How do we actually use this? And I want to kind of mention this. There is an interesting paradox with synthetic data for those that are using it, like healthcare systems. If you have the data initially, why would you try and use the synthetic data? I mean, there are some arguments that other people might have mentioned and have mentioned about, well, it takes less time in terms of IRB review and et cetera. But really, if you have the data, you don't need the synthetic data. The synthetic data really need to be available for the population that don't have any data. And that's a really big deal. We had the same problem with M3C where we had both data sets available. And a lot of people, once they had the real data, it was, why would I go to the synthetic data? But if we can create with synthetic data publicly accessible data sets, we have a really good opportunity to kind of change the field. I mentioned privacy preserving record linkage, and also an aspect of what we might do with synthetic data where it prevents the fingerprinting risk of identification. And we demonstrated that. And then I also showed that example of data sharing where the data from Massachusetts could have helped. At the time we were doing that analysis, I was in Seattle, Washington, and it could have helped us predict the peak of our curve. And then finally, that may be possible, there is a lot of localization of AI in terms of algorithms working at just one institution. And if we can validate things at a local institution and then demonstrate that they could be, that they're robust at other institutions, that would be valuable. Well, that requires data sharing. So going back to the third point, but if you could use synthetic data, you could provide validation at multiple institutions. Finally, Mimic has been mentioned a lot so far. I'm trying here to quantify its influence, which is based on a study that I did with Andrew Tang, where we did a review of studies for sepsis prediction, which is common within Mimic type data sets. We noted that approximately 1/3 of the studies that we found in this systematic review used publicly available data sets, primarily Mimic. And so that one source provides like a 40 to 50% increase in the number of studies that can be done in an area, because it allows other people who don't have the data access to it. And I think that that's a really powerful argument for what we could do with synthetic data. We don't have a lot of mimics, but could we create more versions of that with Mimic? And that's basically finishes up what I wanted to talk about there.
All right. Well, thank you so much, Adam. I'm going to actually, I think, try to see if we can have you be able to start your video and invite
I
all
can
the,
now. Thank you.
Great. I'd like to invite the rest of our panelists to come back on. I have a number of questions for you all, and would encourage the audience and other participants in this to also post your questions either in the Q&A or the chat. So, excuse me. One thing we've noticed, at least in some of the chat over the course of the day, is that we have a pretty diverse set of participants and attendees to this event, from clinicians to very technical folks, and the content we presented so far a lot around tooling. And so my question for you all is, how did you engage folks who may not have been technical, who may have subject matter expertise in their domains, to be able to engage them and have them participate and contribute to the work you're doing? So I'll start off maybe with Rob, then go to Joey, Brendan, then Adam, in the kind of order that you spoke. But it'd be really good to understand, how you develop that team, because in my opinion, interoperability and these things are really a team sport, and you need a diversity of skill sets, and we're all becoming a little more and more specialized. So Rob, you want to kind of kick off?
Yeah, sure. And I don't have a great answer for this. I think kind of in an ad hoc manner, depending on what we're trying to test, we might engage with specific folks that they need to create test data sort of by hand that are experts in that area. We do that. I would love it to be more consistent process, and would love to have more engagement from the subject matter experts here in general. But yeah, I don't have a great answer. Hopefully some of the other panelists do.
Yeah, I think one of the examples, at least some of the calls I've been on around Cynthia, is developing groups of subject matter experts who pair with developers. And maybe Joey, you could tell us a little bit about your approach with the pharmacists around this.
Yeah, so we're kind of weird because we're like the clinical and the technical in one person, the 6 people that were on the competition. So I think we had that in mind, like how not everybody's like us. How do we make this so that there can be collaboration between a technical person and a clinical person? And that was kind of what I touched on a little bit in one of the slides. Was our focus was using something that had an open standard like ARCS norm, ARCS class. And the benefit of that also is that NLM hosts the GUI, or the graphical user interface, that both people, even if they're asynchronous and apart, can kind of look at and say, okay, I think I want this class, instead of a clinical person talking to the developer and saying, I want you to put all the corticosteroids in this module. And they'd be like, what are you talking about? And they could say, oh, it's RX class ID R01AC or something. And they look that up. Okay, so these ingredients. The other thing is the tool we built doesn't force you to go dig into the JSON that gets generated or to dig through a CSV. I didn't mention this, but one of the things that outputs on top of the JSON file and the CSV file is kind of a simple log file, like just a text file that is like the output of that run of MDT. So it's very succinct. It's like, hey, this produced a population level distribution of these meds at this percentage that presumably a developer could run it, could email that back to the clinical person and say, how does this look? Could you evaluate it? Say, oh, I see, we missed this. This is wrong. Let's change these variables. They can rerun it and send it back and forth really quickly and collaborate on this thing without either of them having to have the knowledge that they don't. So that's how we kind of thought through it with this process.
Great, thank you. And Bryn, I know you work with a number of measure developers testing out these FHIR approaches with CQL and folks. How do you engage those who may not be necessarily deeply proficient in FHIR or CQL? And how do you envision that kind of technical knowledge kind of being disseminated to other areas of metrics and measures?
I mean, we have two potential approaches. One is to kind of grow that capacity from the informatics side, to try to get people that are more familiar with the development tools to be more familiar with the clinical space. So trying to come at it from that perspective and enabling through tools like the extensions in Visual Studio Code. So take an environment that someone that's traditionally used to that sort of thing and a tool that they can use and work with, and try to make that something that they can contribute more effectively with. And then we have coming from the other direction, someone that's coming from the clinical space and trying to provide tools that will help them be able to communicate their ideas as well. And so there are lots of different approaches that we've taken. I showed some of them in the slides, like can you get a format that they can use a spreadsheet that they're used to, but be able to provide a set of test cases that effectively results in a lot of content, but is communicated effectively in a way that they're used to dealing with.
Great, thanks. Yeah.
Yep.
And Adam, you have a number of authors on each of those papers you wrote. How did they kind of collaborate to do the analysis in your papers? And
so mostly the authors were, focused on informatics, and we did have some who were clinical experts, but they were already interested in informatics. So I don't know that really shows the engagement of the non-technical folks, because they were all technical. But in our case, we really didn't have to have clinicians or subject matter experts that weren't technical create or validate the synthetic data, because we already had the data and the tool to create the synthetic derivative. Where we needed to engage them was in the understanding of the value in creating the data sets. And for that, we used use cases, primarily like data sharing, which was actually advanced pretty well from the pandemic, where people could understand the value of sharing data across systems, or with linking data sets like the PPRL example. Getting buy-in for creating an accessible data set beyond those in clinical settings like Mimic is a little harder, I'll admit. For clinicians, that seems like a lot of risk without clear value. But honestly, ChatGPT is actually helping in this area, because it shows how far AI has come outside of medicine, and yet how applicable it can be, which creates an argument for advancing AI using more clinical data, which we think the safe way to do that would be through synthetic data.
Thank you. I definitely see an AI kind of meeting like this event in HL7's future. We'll figure out how we're going to organize that. So I want to shift gears a little bit and ask kind of a similar question to each of you, and we'll go in the same order. As you look at the tools that you presented, we'll start with Rob and Inferno, really primarily focused on conformance and certification to meet ONC's rules. But how do you see the value of that particular tool for those who may not be focused on certification, and what would they need to be able to kind of do to kind of learn more about Inferno?
I think broadly we're trying to make Inferno as useful as possible in many different cases as possible. So we're very specifically working on having it be beyond just the certification, ONC certification, and we've done a lot of work around that. We love feedback. If you visited our documentation said plenty of ways to sort of reach out to us, and we would love, I think we're open source and looking to be collaborative, and trying to be as helpful to as large a group as possible. In order to do that, we need I would just love to sort of hear from people to see how we can improve our tools. That's definitely part of our charter here, is trying to make this as useful to as broad a group as possible.
Yeah, so I know, at least in the work we do around the Da Vinci project, one of our fire accelerators, you support different profiles that may not be part of the G10 certification, and it's a great way to help folks understand how to do some validation without being too technical. So,
yeah.
So Joey, you have this great process of using Cynthia for the pharmacy domain. Can you envision folks following your model and starting to develop for other domains? And how would they try to go about that?
Yeah, I mean, I think you can use MEPS similarly, like we did for prescription data. There's other data elements in MEPS that presumably you could do the same thing with. There's like insurance information, other like some social determinants of health information, ethnicity, and like how does that relate to the distribution of medications or conditions or anything else like that. If it could help add some diversity to other areas of Cynthia using the same kind of general methodology that we did for medications, I can see that definitely being possible. I don't know if there's maybe a better way to do it than MEPS or how we're doing it, but I think the same principles could be applied, where we're just our special sauces, pharmacy, and medication. So that was our focus. And yeah, I think even within that and within MEPS, there's other like areas you can expand the pharmacy related features of MDT, like I mentioned, with like modeling how patients in MEPS actually, like, when did they report getting the prescriptions, or were there gaps? That could be like adherence modeling. So there's a lot more to mine out of MEPS by itself in pharmacy and other areas, I think.
Great, thank you. And Adam, do you see expansion of your approach to other
Yeah,
areas?
so we studied MD Clone, which is one tool, and that's a commercial one that we happen to be using at Washington University. And I think the validation that we did of function and privacy preservation was valuable to MD Clone, but that's just one system. For others that are using just different systems, I would hope that our approach for testing or validating synthetic data would be transferable, that by using a similar approach, but hopefully not 11 different studies, but they could choose the ones that were most important to the question they needed to answer. They could answer the questions like, how do we really know that synthetic data works? And I think that's probably the most applicable lesson from it.
Great. So for the audience, if you could put your questions in the chat, and if you have questions, we have one from in the Q&A from Michelle around value-based care requiring a combination of quality measures, clinical data, claims data, and publicly available data. Has any testing been done from a VBC perspective using synthetic data? If not, what needs to be done in order to move in this direction? Bryn, I think you have a lot of experience in some of the quality work, and especially some of the work in Da Vinci.
So there's a value-based care implementation guide going on now. I know there's unit tests associated with that. I wouldn't say there's been like large-scale testing of that sort of thing, but we certainly have unit tests and have been working on content in that area. There are implementation guides that show the use of the same kind of logic and test data applied to both decision support and quality measurement for the same kind of best practice guidance. There are also in the next Connectathon, as I mentioned, we're going to try to start digging more in that direction. We have there's a national payer has provided a certified anonymized data set, and we're going to try to extract content from that, and that would be, I think, a good starting point for a set of test cases around that kind of content.
Other thoughts from the other panelists? So value-based care, I think it's still a little bit of a semantic question. What do you mean by value-based care? So I'll add my commentary. I'm also the technical director for the HL7 Da Vinci project. It's one of our FIRE accelerators that is a group about 50 or plus providers, payers, vendors, health IT folks trying to identify opportunities to use FIRE to improve communications between payers and providers. And actually one of our implementation guides called the Value-Based Care Reporting Implementation Guide is actually going to ballot right now during this particular cycle. And its initial goal is to represent the value-based care report that payers typically send to providers, which today might be in PDF, might be in a slide, might be in most of the time in a non-computable way, so that we can get to the point where we have a standard representation of some of the components of these value-based contracts, risk-based contracts, however you want to describe them, so that ultimately we get to the point where, much like the financial industry, where you hear right now, we're going through these quarterly reports, the financial analysts can compare apples to apples between companies that are similar. And so we hope to be able to do that, because that will reduce a lot of burden for providers when they're trying to figure out whether or not their reimbursement or their cost sharing or whatever is based on information that is really definable and tractable from the payer side. So this is the first pass at this, and the future iterations will look to combine information like how did the provider do on particular quality measure score, all the way down. Ultimately, the goal would be to say, oh, the payer is actually missing some data that we have that's more up to date, and to help them to reconcile that data. So I hope that answers your question, Michelle. There's really value-based care is some really advanced interoperability, given that it may represent contract agreements, measures, other metrics that the payer has, and risk adjustment. And so we are working towards trying to standardize the approach to help reduce the burden for both the payers and providers, and make the data more interoperable and useful. So I'm going to ask, kind of as we wait for additional questions from the community, where do you see the role of HL7, the kind of the regulatory organizations in trying to advance more of this synthetic data usage and testing? So we'll again go ahead and start with you, Rob.
Yeah, so from a testing perspective, I think it'd be great if we can get more standardization of the process of representing requirements across different implementation guides. I think it's actually great in FHIR right now. There's a lot of flexibility to sort of represent requirements in so many different ways, depending on sort of the different situations. So you're not over constraining the folks working in that group on the types of ways that the data exchanges could work, just by enforcing too many sort of standards and sort of discovery process to figure out what the right standards are. But I think over time, and I think it's happening over time, having more and more standard practices and then processes, and then more standard kind of data associated in implementation guides that then downstream tool developers and implementers can then use and ingest and not necessarily have to learn everything about an implementation guide or a given use case to sort of effectively write tests. And at that point, it'd be really great we get to the point where you can have these tools that the folks working on the standards themselves can sort of use it immediately and get immediate value out of, instead of sort of trusting that they're doing things in the right way. And somewhere downstream, someone will use that information that they're putting in there in a standardized way and sort of the right way. So yeah, I mean, that's sort of, I guess, how I hope things move over time.
Great, thank you. And Joey, you and your team really responded to that challenge around the use of synthetic data. What other kind of things would spur your organization and others to really start to advance this use of data and synthetic data for testing?
I think the areas that I've been involved within other roles, like I've done some consulting work with startups that do application development and things like that. And I definitely see the need for Cynthia for producing some test cases for even app developers that are in the health tech world developing software applications and need test data, even if they're part of a healthcare organization. They might not have access to their own data because of IRB restrictions or something like that, as I mentioned before, as kind of the paradox of synthetic data versus healthcare system data. So I can see it being useful for people doing not just health system development and kind of implementation, but people developing software applications in the startup world or that sort of like digital health that need this for testing applications and don't have access to the data.
Great, thank you. And Bryn, you're kind of one of the prominent leaders in the FHIR community and trying to advance this. How would you like to see HL7 doing more to support this, your work?
Honestly, just more of what's happening, where you look across the accelerators, the number of data elements that are being standardized and then being adopted, and you start to see that data then available in APIs. What it does is give you a way to access that data in then your quality measure or your decision support role. So that's one of the areas that we're focusing on, is how do I, as a measure author or decision support, how do I make use of something like the SDOH IG instead of having to define an IG that supports my content directly? Can I make use of all this great work that's going on? And that's really, I think, the key to getting to the next step here, is being able to take advantage of the fact that these different IGs are adding to the pool of data elements that I can then use for data analytics, decision support, all the above. And so that's where I really see the value.
Yes, and I would reinforce what you just said. We need more clinical informaticists, folks who are both bridge that technical and the subject matter experts to learn more about CQL and how that's used in clinical reasoning, because there's some huge opportunities there, but we have to build that community of folks who can work with the tools along with the subject matter experts to represent a kind of clinical decision support in other areas where you're using logic against standardized data to do some kind of reporting. So Adam, how about you? How can folks like NIH or others kind of help to promote more of the kind of analysis you're doing and the use of synthetic data?
Well, so there's two ways. The first way would be, and I talked about this, the methods that we used for a validation of it. And if those could be kind of understood as the standards and rated accordingly, I think that would be a big deal. I don't know if that fits within HL7 or NIH, or maybe even PCORI with the methodology standards in terms of what they're doing for validation. But somewhere it would be nice to be able to say, this is how you test that it's working. But the other place I think it's important to note, especially for a standards organization like HL7, that that's a good example of where you're demonstrating how the standards work with clinical data, but a lot of that is just kind of made up. And so, like, wouldn't it be nice if synthetic data were if there were synthetic data that you were using to kind of demonstrate that as you're doing it? And so that's less in terms of standardizing things and more in terms of demonstrating its utility and advocacy. So I think that those are places. Now, I shouldn't just ask an organization, use it because we said it works. That should be the test of, what would it take for HL7 to be comfortable using it? But just answering that question is going to be valuable too.
That's great, thank you. I want to make one last call for questions from the group. I've actually run through all the ones that we had prepared for, and while we're asking for any additional questions, I want to make a little commentary. It was asked earlier about being able to use these tools, finding them and accessing them. So I want to let you all know that HL7 is working towards a vision we call the HL7 Fire Foundry, which is a testing ecosystem that our goal is to make voluntarily and part of the HL7 kind of processes, these open source tools more readily found, and then provide a process where you can actually start to actually manifest them and host them, either in your own hosting or as appropriate for the tool in an HL7 hosted area. Because I think one of the challenges we have with testing is that it takes a lot of time to prepare for it, Connectathon, and put together all these tools in a tool chain that is coherent and understandable. And that's why I think some of the challenges for the non-technical folks is to understand how all these pieces come together. So we're certainly working on this vision to create this ecosystem that we can make the tools available, along with ideally also the synthetic data that would go with it, terminology services, and really provide a sandbox for to support testing across a virtual ecosystem, a virtual sandbox, beyond what we typically do today around client server testing. So we'll have a brief update about that during our upcoming HL7 working group meeting in Phoenix coming up in a couple of weeks during the Connectathon. And then we'll have a webinar probably in Q4 of this year to kind of update the community of where we are in trying to support testing and testing tools and making them more approachable to a wider audience. So I'm going to take one last look, see if we have any additional questions. I don't see any. So with that, I want to really thank all the panelists for your presentations today, for your all these questions you've been answering. I hope the community kind of understands how we're using these tools, and we look forward to your participation in the rest of the event and providing feedback as we go along. So thank you all. We are now going to take a 15-minute break. So you guys can catch up a little bit on your email or such. So we'll resume at the bottom of the hour, which is 3:30 Eastern time, when I will also hand back the baton to Dan Vreeman, who will be moderating and facilitating the final part of our event for today. So thank you so much, and we'll see you back in about 15 minutes.